Hi everyone, this is Mrs. J, and today we're going to be multiplying and dividing rational expressions. Right before we get started with that, I have a quick warm-up for you guys, so please pause the video and give it a try, and when you're ready to check your answers, you can hit play. Alright, go ahead and check your work here. Make sure you start by factoring your denominators, and then just a little tip, if you have 1 minus x and you see you have other denominators that are x minus 1, which is the opposite, we can actually factor out a negative 1, and then 1 minus x becomes x minus 1. So notice this becomes negative. Now before I combine all three, you can actually combine the two on the right because they have a common denominator. And then if you multiply that new expression by x plus 1 over x plus 1, now you have that least common denominator and you can combine your last two. And then from here it's just a matter of adding together everything in your numerator, and here's your final answer. And then we do want to add in our restrictions, so we see that x cannot equal negative 1 or positive 1. So today we're going to be multiplying and dividing rational expressions. So it's going to be the same basic rules that we follow when we're multiplying or dividing any fractions. For multiplying, you multiply across the numerator and across the denominator, and of course anything in your denominator cannot equal 0. And for dividing, we actually multiply by the reciprocal of our second expression, giving us a times d over b times c. And here you have to make sure with your restrictions, anything that was at any point in your denominator cannot equal 0. So you can see that b cannot equal 0, d cannot equal 0, and c cannot equal 0 because when you multiply by the reciprocal, it ends up in your denominator. Okay, so let's try this first example together. Here we're multiplying two rational expressions. So the first thing I am going to do is factor everything as much as we can to see if there's anything we can simplify out. So we have 3x squared over x minus 4 times x plus 2. And then here we can factor out a GCF of 2. So that numerator would leave us with 2 times x squared minus 3x minus 10. So x minus 5 times x plus 2. And then here we have x minus 5 times x plus 2. Now before we start crossing anything out, common factors, I want us to look at the denominators and list out any restrictions now, because even if they are removed, they are still restrictions. X cannot equal them. So we can see here that x cannot equal positive 4, negative 2, positive 5, and then negative 2 we have already listed. So we're going to list all our restrictions first, and then we can simplify our expression. So these are going to cancel out like this, and then I'm going to multiply across the numerator and across the denominator. So we're left with 6x squared over x minus 4 times x plus 2. And we can leave our denominator factored. So here's our answer, and here are our restrictions. All right, let's try another one. So here we have, we're multiplying again, so let's factor. So we have x times x minus 8 over 14 times x plus 5 times x plus 3 times, and here we can factor out a GCF of 7, so 7 times x plus 5 times x plus 8. So from here we can list out all of our restrictions. So we say that x cannot equal negative 5, negative 3, and negative 8. Those are excluded values. And now we can multiply across the numerator and the denominator. So here we have x times x minus 8 times 7 times x plus 5 over 14 times x plus 5 times x plus 3 times x plus 8. And now we're going to look for common factors. So we see a common factor of x plus 5. There's a common factor of 7. So in our denominator it becomes 2. And then what's remaining will be our answer. So we have x times x minus 8 over 2 times x plus 3 times x plus 8. And this is going to be our simplified answer. So this is our answer, and again, these are excluded values, which came from the denominator of our original set of expressions. All right, so can you pause the video and give this one a try on your own, and then hit play when you're ready to check your answer. All right, go ahead and check your work here. So our simplified answer should be x minus 3 over 2x times x minus 9. And don't forget to list your excluded values by looking at the denominator of your original expressions. All right, so now let's try a division problem. We're still going to start by factoring everything completely. So we have x plus 7 squared in our numerator over x squared divided by x plus 7 times x plus 2 over x plus 2 times x minus 1. So before I multiply by the reciprocal, let's list out some of our excluded values. We'll have more after we multiply by the reciprocal. So far we see that x cannot equal 0, -2, or +1. But again, when I multiply by the reciprocal, so we're going to actually multiply by x plus 2 times x minus 1 over x plus 7 times x plus 2. I now have to look at this denominator, and I actually have an additional excluded value. So I see that x cannot equal -7. And here we have already listed -2, so we've listed all of our excluded values here. So now I'm ready to multiply across the numerator and denominator. So we have x plus 7 squared times x plus 2 times x minus 1 over x squared times x plus 7 times x plus 2. So x plus 2 cancels out, x plus 7 cancels out, and what I have left is x plus 7 times x minus 1 over x squared. Again, our excluded values are listed over here on the right. All right, let's try one more of these together. So I'm going to start by factoring. So I have 6x times 3 times x minus 10 divided by, so here if I divide out a GCF of 9, I'm left with x squared minus 3x minus 4. So we have 9 times x minus 4 times x plus 1 over x times x minus 10. So let's list our excluded values that we see from here. So we see that x cannot equal +10 and 0. So that covers all of the denominators so far. But then I need to multiply by the reciprocal of our second expression. So now we have some new values or some new terms in our denominator. So we can see that x also cannot equal +4 and -1. So we have 4 excluded values, and now I'm ready to multiply the two expressions. So we have 6x times x, so 6x squared times x minus 10 over 27 times x minus 10 times x minus 4 times x plus 1. We can simplify our coefficients, our leading coefficients. So both are divisible by 3. So we have 2 over 9. X minus 10 is also a common factor. So that leaves us with 2x squared over 9 times x minus 4 times x plus 1. Again, our 4 excluded values are listed over here on the right. All right, so I have another one for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check your work here. So remember, we need to list our excluded values from our initial problem here. And then actually when we multiply by the reciprocal, The two other terms that end up in the denominator give us values we've already listed. So x cannot equal 0 and 8, so we already have them. So from here, you just multiply and then simplify anything you can. All right, so now we're going to practice simplifying what are called complex rational expressions, which are just expressions that have fractions within fractions, something like this. So for problems like this, there's really two different ways you can approach them. So I want to show you both ways, and then you can decide for each problem which method you think will be easier to use. So one way you can address these problems when you have fractions within fractions is to actually clear your tiny fractions altogether. By tiny fractions, I mean the fractions within the numerator or the denominator. So you can actually clear those by multiplying the numerator and denominator by the LCD of your smaller fractions. So you look at all of your smaller fractions. In our numerator, I don't have any smaller fractions, but in our denominator I have 2. I'm actually going to rewrite the problem right here. So I look at these denominators and I find the least common denominator of those two numbers, and our least common denominator would be 50. So I'm going to actually multiply the numerator and the denominator by 50. So when I do that, this is actually going to clear our smaller fractions. So here you have to distribute it out. In our numerator, I'm just left with 500. And then here I have 50 divided by 2 times u, so 25u. And then here I'm left with 2u. So you can see that now it's no longer a complex rational expression, it's just a rational expression. And I can combine like terms in my denominator, and now it is completely simplified. And so this is our simplified answer, and our excluded value is that u cannot equal 0. A different way of doing this, which some people prefer, is when you have two fractions within your larger fraction, you can actually add the fractions and then simplify. So this was method 1, here's method 2. So when I say add the fractions, I mean we're going to add the two fractions that we have in our denominator. So here we still need to create an LCD between the two. So we're going to multiply this by 25 over 25, and we'll multiply this by 2 over 2. So we get 10 over 25u plus 2u over 50. And then from here, that gives us 27u over 50. So here I am just, I'm dividing by a fraction. So remember, dividing by a fraction is you just multiply by the reciprocal. So this is really just 10 times 50 over 27u. Again, I'm just multiplying by the reciprocal of our denominator, or of our second expression. And then we end up with the same answer as with our other method. We get 500 over 27u. And we have that same excluded value, that u cannot equal 0. So again, this is just two different ways to approach these types of problems. So again, one, you find the LCD and you multiply the numerator and denominator, and that should clear all of your fractions, your smaller fractions. Or you can actually add the fractions that you have and then just simplify from there. Remember, when you have something divided by a fraction, you just multiply by the reciprocal, like we did here. All right, we're going to try one more together. So I'll go through those two methods with you guys, and then again, you can decide what would work best for you. So let's try the first method, which is clearing all of the fractions by multiplying by the LCD. So multiply by LCD. So I'm going to rewrite the problem here. Okay, so if you look at all of your smaller denominators, we can see that our LCD is 5u times u plus 2. So I'm going to multiply our numerator and denominator, so that means every single term in the numerator and denominator, by 5u times u plus 2. Okay, so then when I multiply this LCD to this first term here, you can see that the u's cancel out, and I'm just left with 125 times u plus 2, because I have 5 times 25 times u plus 2. And then when I multiply my LCD to this term, the u plus 2's cancel out, and I'm left with 25u squared. And then in my denominator, here the 5's cancel out, so I'm left with u times u plus 2 squared. And then here the u plus 2's cancel out, so you're just left with 5 times 16 times u, so plus 80u. So you can see that once I've done that one step, I no longer have a complex rational expression, I just have a rational expression. And then from here, it's just a matter of multiplying everything out to combine like terms. So in the numerator, we have 25u squared plus 125u plus 250. And then in our denominator, I can do some of this on the side. So we have u times u squared plus 4u plus 4. So that becomes u cubed. And then I have plus 4u squared. And then here I have plus 4u plus 80u, so it becomes plus 84u. So now I can try to factor to see if there's any terms that will simplify out. So in my numerator, we can start by factoring out 25. So we have u squared plus 5u plus 10. And then in our denominator, we just have u times u squared plus 4u plus 84, which you could try to factor. You can't factor it anymore. So this would be our simplified answer. Now for these, when we're doing our excluded values, we need to be careful. We need to first look at all of the smaller denominators that were in our original problem. So I can see from the original problem that u cannot equal 0, and u cannot equal -2. And then you can look at the denominator of your answer. So this gives you that u cannot equal 0. And then you should set this equal to 0 and solve. In this case, this would give you imaginary answers. So if you did quadratic formula with this, it'd be imaginary. So we don't use imaginary answers as excluded values. So we only have two real excluded values, 0 and -2. But you do need to look at your original problem and any denominator from your original problem as well as your simplified answer. Now, if I were to do this with that other method of adding the fractions, okay, it would look something like this. Let me rewrite the problem again. All right, so for here, again, our goal is to add the two fractions in your numerator and then to add the two fractions in your denominator. So turn it into a single fraction over a single fraction. So for this, I need to multiply by u plus 2 over u plus 2. And here, we'll multiply by u over u. And then we need to create a common denominator here as well. Okay, so this will give us 25 times u plus 2 plus 5u squared over u times u plus 2 all over u plus 2 squared plus 80 over 5 times u plus 2. So before we worry about multiplying by the reciprocal of our second fraction, let's actually multiply out our numerators here and combine like terms. So we'll have 5u squared plus 25u plus 50 over u times u plus 2 divided by u squared plus 4u and then plus 4 plus 80, so plus 84 all over 5 times u plus 2. So from here, we're ready to address this multiplying by the reciprocal of your second fraction. So we can rewrite this and, write this times this reciprocal. Just a little shortcut I have so we don't have to rewrite it. I call it a double rainbow. What you do is you multiply the very top to the very bottom, and that becomes your new numerator. So our new numerator is 5u squared plus 25u plus 50 times 5 times u plus 2. And then we multiply these two inner terms here, and that becomes our new denominator. So u times u plus 2 times u squared plus 4u plus 84. And really all I did was multiply by the reciprocal of our second fraction. And then what we see here, we have a common factor of u plus 2. And then here you can factor out a GCF of 5 and then multiply it to the other 5. So we get 25 times u squared plus 5u plus 10 over u times u squared plus 4u plus 84. So you can see that we end up with the same answer here. We would have the same set of excluded values. So again, we look at our original problem. So we look at these denominators and we look at our simplified version to list our excluded values. So again, these are two different ways you can address these. I think my preference would be multiplying the numerator and denominator by the LCD just to clear your tiny fractions altogether. But some people do prefer adding the fractions and then just doing double rainbow or multiplying by the reciprocal. So it's up to you which method you prefer. And maybe for some problems, one method looks easier than the other. All right, so here I have one last you try. If you could pause the video one more time and give it a go, you can hit play when you're ready to check your answer. All right, go ahead and check your work here. So I have the two different methods, multiplying the numerator and denominator by the LCD, so that method's kind of on the left, and then combining the fractions within your numerator and denominator. I have that method on the right. Either way, you get the same answer, the simplified expression. Here you actually have three restrictions. X cannot equal -4 comes from the original problem because x plus 4 is in your denominator. Then if you look at your answer, we have the factor x squared plus 8x minus 59 in our denominator. So we need to make sure that this is not equal to 0. Now you can't factor it to find the zeros, but you can find those zeros using the quadratic formula. So x cannot equal -4 plus or minus 5 root 3. So again, sometimes your excluded values are irrational, but we do want to list all real excluded values. Okay, that is all for today's video. Thank you so much for watching.